So my screen is sharing. Will you able to see it?
Okay, clear.
Okay. All right. Assalamualaikum. Very good morning, everyone. My name is Mas Farita from Project Delivery and Technology Petronas. I'm currently the Industrial Hygiene Staff Engineer. Glad and honored to be here today, and thank you very much for HFEM for the invite. Under Industrial Hygiene at Petronas, we take care of the ergonomic implementation. And when I joined Project Delivery last 2 years, all the HFE projects, design review have already go down my plate lah. So basically, I previously had experience at the upstream business for 14 years, and very new with project delivery, engineering design, and technical delivery in my current role. So about 2 years. I am currently also the full member of Malaysia Industrial Hygiene Association and Human Factor Society, HFEM. And in 2021, I become professional member of the Board of Technologies. Okay, and at our business sector, currently we have a strategy and initiative, or like a specific focus area of the year for our business, which we call Human Factor Management Initiative, in short, ROBUST, whatever name that we want to make it big lah. It's called ROBUST, and it's part of our scorecard reporting to our SVP, where we want to enhance the human factor implementation throughout project implementation, project technology design. So as Petronas, we are at the front end of new technology that comes into Petronas lah. So unlike upstream or downstream business or chemical business, we are the one that receive, or we are the one that introduce new technology from throughout the world to for the implementation within the company. All right, and so my experience doing HFE is basically about 2 years ago, where I have to indulge myself in human factor engineering, design review and whatnot. So and I depended a lot on all other HFE specialists. But what I'm sharing with you today is the fundamentals of human factor engineering, basic things that you need to do during any process design. So from my background of oil and gas, a lot of these examples that I'm going to share will be oil and gas facilities examples lah. Also, as a start introduction to HFE, so what's wrong with these pictures? Anyone experienced this or not before this? So kalau nampak, maybe it's a little bit small. Left hand side toilet, and then ada the picture of the lady and the guy, but the label on the door is actually men on the left and women on the right. So nampak macam you're going to step in the wrong toilet if you don't read the signs betul-betul kan. And gambar keep right, but with the arrow left.
Puan, sorry. Maybe slide move.
Dia tak move eh?
Okay. Puan, tapi slide tak dalam slideshow.
Okay, sekejap. Saya escape tadi. Alright. Dia move tak? Now?
Dia move tapi belum slideshow.
Oh, dia tengah slideshow.
Oh.
Dah ke? Belum slideshow eh? Oh, apa yang dia buat ni? I unshare and
Share dulu.
Okay, tengok kalau dah slideshow.
Belum Puan, tapi macam clear je. Maybe okay.
Dia ada keluar gambar toilet tadi. Gambar toilet pula.
Belum. Dia tak keluar.
Ah,
Sekarang ni slide number 3.
ya, tapi dia tak slideshow
Ah. Oh, ada tu, dia ada.
So it will be small kalau tak slideshow tu. Tak slideshow
Tak.
How
Ataupun
is it?
when share first.
Entire screen lah.
Ah.
Macam tu. Sekejap. Macam ni
Okay, slideshow.
Cuba
Lama.
Alright, so what's wrong with these pictures? Toilet tadi. And the arrow left but the sign says keep right. So example ni bukan dekat Malaysia lah, I harap. And the other one, have you ever experienced this? Dispensing money from ATM machine. So on the top is the instruction to insert here. Insert your card here, whereby the card slot is on the top. Funny, right? And on the below one, have you left your ATM card? Have you ever left your ATM card where it is designed to dispense cash first and then card? Nah, used to be in 10 years ago kau pernah juga keluar duit dulu and then baru kad. So dah dapat duit kita pun jalan, kad tertinggal. Pun pernah jadi biasa kan? So these are examples of HFE in our day-to-day life, right? And on the right-hand side are the examples that I took from IOGP. The technician who works at the oil and gas plant, and on the most right is the one that is working on inside the ni macam petrol station So the guy on the left hand side ni, he has a lot of button to press and he is obstructed with pakai apa pipe racks in front of him. So that pipe racks, how is it being designed in front of a control panel atau a panel like this? Is it supposed to be there or is it not supposed to be there? And will he be able to press the right button or not? Because somehow we have information, is basic information that about 8% of the male population is colorblind. So what do you think will happen in this picture here? And on the right hand side dekat petrol station, ada banyak berlingkar kan the hose tu, and it's all the same colours. Do you think this guy boleh can make some mistake of installing the wrong hose to the wrong input or the wrong nozzle? So if wrong nozzle, what do you think the incident would be like? Will it not be very catastrophic in ini petrol station dekat sebelah rumah kita ni? Macam tu lah. So this was designed maybe many years ago, and it has become a classic example of IOGP lah, of how to design it right on human factors. So throughout the world, just examples of historical and catastrophic incident that HFE has caused the lives and the industry. So not only it affects the dollars and cents, we learned that it actually, human factors actually has become a lot of findings from, the first one is Piper Alpha. This is a classical example of oil and gas incidents happened in 1988, and among the findings are monitoring panels not clearly visible, so technician not able to tell where the alarms originated from. Too many non-critical alarm. Pressure valve was out of sight for night shift workers. Manual firefighting system fails to follow accessibility to guidelines. So these are among the human factors real examples that create that become the root cause for Piper Alpha. And the more recent one, Deepwater Horizon, everybody watched the movie, right? And we found out that from Deepwater Horizon, there was no camera to monitor the activity. So you can imagine such a hazardous and very risky activities. There were no camera or any CCTV around that. No sensor to indicate position of valve, sending returns overboard. Low accuracy of sound instrument center, no automation. Automation ni automate lah, rather than human intervene it. We should be doing more automation rather than ambil kira satu-satu pakai pensel and scales of display made it hard to see fluctuation in data. Okay, and many more example. BP toxicity, Formosa vinylchloride. Okay, yang ini I can share with you. Formosa vinylchloride, the outcome of the incident showed in the video is actually the technician turun tangga from the first floor to the second floor. Nampak tak, the tangga turun and then he has to turun ke bawah, then he has to turn left and then baru dia sampai to the reactors, right? So that guy who was working that day, he forgot which is his left or right. Is it left or right? Yang sepatutnya dia turn on. Instead of turning left, they turn right. And all these reactors look the same. Dia tak ada indication pun this is reactor A or B or whatnot. It looks the same for him and apparently he is doing the job on the wrong vessel. Hence, teruslah the vinyl chloride tanks meletup. Alright. So these are some of the examples why human factors are important. And I would like to share that we are trying to integrate human factors in our design processes. So currently in the company that have been working with, we are lucky that we are already embedding human factors in the design. And what we are looking at now is human factors throughout the organization, throughout the day-to-day operations, and what more can we do to reduce incidences. So what I'm going to focus today is more towards the design, which we already have maybe about 5-10 years ago in the system. Yeah? Benefits of HFE in design. So the application of HFE considers the capabilities and limitation of people and uses this information to ensure optimal design of workplace systems, equipment, and the working environment. So there's a lot of benefit. The first one is improved safety, reduction in risk by reducing the likelihood of human error and violation. So the first one is our human factor SNI, we call it just now, is the objective of our SNI for this year, to reduce likelihood of human error and violation. The second one is reduction in project costs by ensuring right first time design and avoid the need for expensive changes and rework. So kalau kita betul-betul follow the design and design it right the first time, so we may be able to avoid redo or re-engineering of a specific system, because all of this re-engineering work require man hours and penat lah, kita dah design cantik-cantik, dah buat all the calculation, but we have to redo the work just because of some human factor errors at the end of the pipeline that we found out later after kita dah pasang, dah siap the plant. The third one is improve human performance and task efficiency and leading to higher productivity and operational capacity. So this one comes without saying, bila kita selesa buat kerja, when we are very passionate or very highly productive, very motivated to do it, when you turn or you press on the button, when you turn the valve, you don't feel so fatigued, you feel relaxed, you feel so selesa, comfortable, you will be very highly productive. Okay, so it is a win-win to the company and to the worker. The fourth one is improve working condition leading to high job satisfaction, which I just mentioned just now, and reduce absenteeism and staff turnover. So tak adalah ramai yang balik-balik tender resignation, resign. So HFE design process is focused on the physical aspect of the workplace, and it is an iterative process. So that's why we say try to get it right first time. However, we still understand it is an iterative process. Iterative means when you stumble, you face a stumbling block, you redo it again. Stumbling block, redo it again until such time you learn and what is the best solution for that particular design. Then only you proceed. Hence, you will design it right the first time. So in this webinar, hopefully within this 1 hour, fundamentally HFE design process that I would like to share with you are the HFE screening, valve criticality analysis, task requirement analysis or safety critical task analysis, CTA, and a few specific design analysis that I have been working with. I will cover some on design, human-machine interaction, and design of the workplace. LQ work location. So overview of HFE design processes. So this template here is actually readily available in the open web. You just Google it for human factors engineering in projects report 454 by International Oil and Gas Producers. So this actually shares with you HFE integration within a project design lifecycle. So if there are other companies who is heavily involved in engineering design, or you want to design a plant, so you can adopt these HFE design processes within your company, whatever processes that you already have in the company, whatever management system that you have. So you should start from select, which is the concept selection. Here you can carry the HFE screening. You may need to develop HFE strategy, HFE integration plan, and establish some RASI, roles and responsibility, and set up some mechanism of managing HFE issues. After that, you should go to define, execute, and operate. Operate means it's already in full plan operation mode lah. So the select, define, and execute is you start from zero. We call it greenfield. Greenfield tu macam as good as you start daripada tanah, ratakan tanah dekat kawasan tu. So greenfield is you start with nothing. There's no development. You just get a piece of land. So if you have a greenfield project, you must be able to integrate all of these elements inside your processes. But if you have a brownfield project, brownfield is something where you already have some development within the area. So you just step along with that development. So maybe dia dah ada jalan raya, dia dah ada some other building. So you just step along and you adopt whatever HFE elements inside there. Okay, so for the details, you go through the IOGP report. It has some definite explanation of each of the items here. So here are the examples of HFE evaluation exercise in an oil and gas setting. So in oil and gas, in my current job, these are the basic project management system processes that we do, starting from framing to front end loading. Front end loading is divided into 3 phases: front end loading 1, 2, and 3. And then after completion of front end loading, you proceed with execution, and then only we move forward with start up of the operation. So front end loading atau dulu nama yang kita panggil is front end engineering design feed. So it's actually about the same. This is the process where all basic engineering data needs to be fed in, and hence HFE data or HFE initiation should start from this phase. So in simplicity, HFE starts at file 2, where the scope selection is being done. So within the company, our scope selections will start with integrating HFE initiation processes, and moving on, scope definition. That means the design of the facility is about 90-80% confirmed. So in file 2 or file 1, you just have a black box. You don't know what the process will be like, and at file 3 you already have something in mind. You wanted to go to detailed design, and at detailed design we will have design analysis and verification. So the fundamentals of what I mentioned just now have been embedded here. So fundamentals dekat valve, the safety critical task, all the specific designs should be embedded here dekat detail design. And towards executions means building ataupun constructing the building. That's where you validate or you check balik whatever the design that has been put in the PNID, that have been commented, that have been updated, is really built as per our requirement just now. All right, so these are the overall processes of project execution in a typical oil and gas setting. So just put that processes inside your head. Framing, front-end loading, execution, and startup. So at HFE screening, so HFE screening, we conducted through a checklist which helps to identify what are the HSC or health, safety, environment philosophy. So always when we design a workplace is we need a worker to work for it. But if we don't take care of the safety of that worker, how will a business entity benefit from it? How will a business entity gain money from a place where no one wants to work in it? So hence the first one that you have to define is the HSC philosophy. So whether you want the worker to be present there all the time while you are introducing a lot of other hazards surrounding him, noise, combustible gases, toxic things. So you need to know that in the HSC philosophy, among the things within the HSC philosophy will be HFE screening. So there are a lot. So during the screening, you list down all the technical standards that you want them or you want the designers to follow. So technical standards are ranging from Malaysia, industry and other international standards that we want to adopt. And then you taking cue from the standard, you put it inside all the requirement in the project and merge it together, discuss, debate, how will it be managed for full scale, how will the training be, what are the assurance like, and if anything goes wrong, how do we deal with the risk? How do we deal with the unprecedented scenarios of emergency situations? Okay, so those factors should be part of the screening topics, and there are to guide you, yang ini kita akan ada satu lagi slide lepas ni. To guide you, the screening factors should include task complexity, unique criticality, task frequency, novelty of the design, and design scope, and known problems. So there are 6 items that you have to consider during the screening. So I mentioned just now about the technical standards. So HFE standards review, it is an additional step to identify what are the standards using a checklist to check on the applicable standards guidelines within the world that you want to adopt. It can be ISO, it can be any US-based, NIOSH, OSHA, ASTM, NFPA, and whatnot. It's a lot. So HFE screening and even HFE standards review, not a one-man show, is normally done in a workshop setting. The third one is on human factor integration plan. So this aims to provide detail on how HFE consideration will be integrated. So this is where I think there is a slide on this. This is where you will define at what level HFE specialists will come in. All right, so we are going through the first one. The first fundamental is on HFE screening. So HFE screening is a method used to assess HFE risk and whether the project requires further detailed HFE assessment. Okay, so each project, you must know, when you want to do a project, you must know what it is, right? So you must know what you want to build, how big you want to be, what are the resources, berapa banyak billion dollars that you want to invest, billion ke million ke, tak kisahlah, whatever definition that your bosses want you to work on. So you must know, and then what is it that you are selling afterwards. So you nak create a building atau a project, a facilities, you want to build something, you want to sell something, right? So nak buat apa, kita buat something tapi tak menjual something kan, so tak dapat apa-apa input pada income kepada kita. So you want to sell, I don't know, a kilang, a certain kilang lah. So you must know product dia apa and what are the potential issues from the kilang. What will be the emission, what will be the hazards that you are going to put your worker in, what will be the impact to the people surrounding community. So those are the things that you need to know and put it inside the HFE screening criteria. So the objective is to recognize the risk, identify what HFE activities that need to be done, and we have to determine whether this risk is acceptable or not. So at this stage, if this risk is not acceptable at all, and even by the stakeholders or your internal bosses, your project manager, so you should not go forward with it. You should define ataupun you should address that risk in another way. So some other you drop it from the scope, you not design it, you not put it in the design or something lah. But this is where the screening, this is the important part of the screening where you need to do the identification of the risk. Uh, there you go. So HFE screening is at the top of the HFE planning and sourcing. So on the left hand side, process flow for the HFE screening and sourcing, which I took from the report 454 OGP. So this is overall lah, overall implementation start from screening. So is it yes, no? Kalau yes, you do the HFE screening, and then you must identify what are the required HFE design input, and you need to estimate level of HFE specialists, and then ada some description within the annex, and then based on the level of HFE specialist input, low, medium, high, you will need to see whether you need to decide whether HFIP integration plan is required. So if not required, there will be a set of strategy. If recommended, what strategy, and if required, what will be the strategy. So these are very specific, well defined within the report 454. It's just snapshots you the preliminary HFE screening checklist. So this is the most top part of the flow ni lah. And so these are the questions that you need to answer before you start anything. Okay, so kalau if the project already started dekat jangan start dulu kata dengan bos, we need to do HFE screening dulu. After that only we can decide on whether we want to proceed with some of the risk or not. Okay. Okay, these are the example of HFE screening and HFE standard review checklist that we use. You can just utilize a normal Excel checklist. Adopting the 6 item just now that I mentioned, task, complexity, novelty, and all that, ada 6 tu. So the task, complexity, novelty, each of these 6 items are already specified in the OGP 454. Look out for it. They are available at the appendix, the table A4 and table A7 are just an example. So what we did in the template of the HFE screening, you need to list down all of this type of systems. Jenis one system of the project. Maybe macam ni example, fuel gas hot and hot oil system. So if that is a system that works, a system is something like just one big process that start and finish till the end within the overall big design of that facility. So you list out all the system and then go to the 6th question of the HFE screening tadi. So that 6 question you have to decide dekat satu stop tu lah, task complexity, unit criticality, work frequency, novelty, design scope and whatnot. And finally you will land up to whether you want to have further assessment. Okay, so that is the screening part. The intention is to see whether you have to go forward with additional assessment. And then the standard review is just an additional way how we want to make things better implemented. So there is a workshop to decide what standard, what ISO to use, what NIOSH method or whatnot. So, but we just use a simple template lah. Something like, does the project scope include offshore living quarters, onshore living quarters, or non-process building, or maybe toxic gas release shelter? You know, those are more critical kan. So if yes, then you put in all the standards that required. If no, then not applicable. Okay, so it's quite simple and straightforward using this kind of standard. Okay, after the within the HFE screening, on completion of the screening, the facilitator should use the result as the basis for preparing the HFE strategy and subsequently a human factor integration plan. So remember the flow just now from that 454 table. So start from screening up to below, coming below, there is a portion of human factor integration plan. So that is where you decide this project or this facility will require low, medium or high, what kind of integration HF specialist that you required, and whether HFIP is required, it depends on the estimated level of the specialist output. So is it low, medium or high? So low actually no, not required. HFIP is not required. Medium is when HFIP is highly recommended but not mandatory lah. And high is that standalone HIP is required, HFIP. Okay, so go back to OGP 454 and look for the process flow just now. So far so good, yeah? So we are moving into the second one, okay? So the second fundamentals is on valve criticality analysis. So the first is on screening. The second one terus kita pergi ke valve. Kenapa valve ni? What is so special about the valve? You might be thinking right now, right? So we have not gone through the anthropometry apa lagi kan. But the first part, I also have the same question. The first part, why do I want to talk about valve? Valve criticality analysis, if you have a process system, macam dekat rumah, if you have a wiring system or a piping system, valve ataupun you need an output of that thing, that system to be able to utilize by you kan. So if you don't turn it on atau buka the valve ataupun pilih air tu, the water will not come out. So and if the water come out and you cannot, tiba-tiba ada rosak dia punya pilih air, tak ke catastrophic kan dekat rumah, dia banjir, nak menyusahkan. So valve criticality is the same analogy that I would like to adopt dekat processes, plant processes. It is critical because with this valve, it allow the process to take place. So if you close the valve, the process will not take place. Tak jalan lah, macam air kan. So it is very important where the valve is working as per intended use. There are valve supposed to work, supposed to fail when it's supposed to do. There are valve is supposed to work when it's supposed to turn on. Faham tak? There are a lot of type of valve lah, pressure control valve, pressure reliever and whatnot. So ada situation valve yang kita memang nak dia tutup when the pressure is too high. There are some valve that we want to open when we want the process to flow. So hence that is my understanding why valve should be the first one that we have to consider. So what is VCA? VCA is the identification and classification of manual valve according to their criticality from the HFE perspective. So why we need VCA? To raise awareness on the critical function of the valve and serve as a guide to design and locate the valve, which location kita nak letak dia kan. Itu pun important. To facilitate safe operations and maintenance. So when do we need a VCA? VCA shall be conducted after HAZOP, after incorporation into HAZOP, before 3D model review. So within our process, we have several segments of 3D model review at 30%, 60% and 90% completion. So daripada, ingat tak daripada black box tadi saya sebut, daripada black box sampailah nak jadi, dah nak rupa pelan tu dah nak siap dah. So 30%, 60 and 90% will be all of the decision making about the valve will be made there. Alright, and the important goals are to reduce human errors and minimize safety incidents. So kita nampak insiden yang tadi, yang asal slide yang awal tadi, there are a lot of safety catastrophic incident that originates from valve fail to perform as its intention. So to ensure ease in operation and ensure efficient use and minimal human efforts. Right, and valve shall be rated by its criticality to ensure that critical valve can be operated effectively and swiftly as per intended use. Okay, so first what we do is we define the criteria for valve category based on the PNID markup. So at the first start of the decision, we should have a PNID lah. So PNID ni is an engineering drawing. Okay, drawing depending on what phase, if it's a basic engineering or dah detail design kan. So biasanya we will do it about tengah-tengah in between basic dengan detail design tu. So we define the valve, kita define that valve based on these three category. To classify the valve in an effective manner, the following question should be used. So is it a critical process to process or operation? Is it critical for process guarding or emergency? So is it frequently operated? Is it more than once a month or not? Right? And these are examples of the worksheet that we use. So what we do here at each of the section or the module, we list down all the valve that may be that will be present there. So valve description, and ada some tag number. And you know that three question just now. So answer that three question: criticality, valve, process operation, safeguarding emergency, or operated once in 6 months or not. So based on that, So based on this question, you will get this criteria decision making. So you will categorize all these valve into C1, C2 or C3. So C1 tu memang colour merah, C2 memang yellow, and C3 is green lah. So what it means is that the red one is the most critical, the yellow one is second critical, and the green one is okay, tak ada masalah. When we have this result, then you will send it to the next level, which is valve accessibility requirement. You have this list. This is where your HFE team, you put that requirement for them to design the valve as per C1 requirement. So C1, among the things that I read here, height and reach distance shall conform to the preferred location. Permanent accessibility shall be provided. It shall not be located so they have to be operated from ladder. Okay, itu yang yang red. Okay, so those valve that are critically C1 rated must be designed as such. Okay, sama juga dengan those valve yang dah rate as C2 and C3. So definition dia, how it should be designed is defined in this table. So basically at green, permanent accessibility to this valve is desired but not essential. So that's how we prioritize lah. So it's actually a prioritization effort lah kat sini, okay? So far so good. Alright, so we are moving on to the third fundamental is which is we call safety critical task analysis or SCTA. So ada juga kita panggil critical task analysis, sama je nama dia, SCTA or CTA. It is a methodology for undertaking human error identification and assessment to demonstrate that any risk associated with human error will be reduced to allow. Alright, and it typically defined as any routine or non-routine task. So this one involved human. So we want to identify all the tasks, is it routine or non-routine, that can create or initiate major accident hazard. So the task may involve physical or mental, and it can either be human-machine interaction or human-human interaction. Access and layout associated with the non-routine hazardous operational activities should be reviewed during the HFE 3D model review. Okay, so basically the overall purpose is to evaluate critical human tasks to ensure the design has incorporated the features. So the process of SCTA, there is already a process on its own. So for the example yang dalam gambar ni lah, identify main hazard, identify and prioritize critical tasks, understand the task, represent critical tasks, identify what are the human error and what are the performance influencing factors. So these are macam KPI for human performance, HPI. Determine safety measures to control human failures, implement and monitor effectiveness of safety measures, and review overall process. So for SCTA, the template also quite straightforward. You can create a as a sheet out of it lah. Description, any further information, what are the potential human failure, what are the human performance influencing factors, and what are the mitigation measures. So basically kita, the flow ni kita jadikan dia dalam table, and from OGP 454 you will get all these guide words, guide words of action failures, uh, checking failures, action failures and whatnot. So you start, you list down all the steps, and then describe the step, what are the additional information. So is there potential human failure? So you go through the guide words one by one. Operation too short, too long, operation mismatch, operation in wrong direction. So that process you have to go through one by one. Okay, so kalau ada team doing it, it will be faster lah. But if you doing it seorang-seorang, penat sikit lah. You have to go satu-satu soalan ni kan. And and performance influencing factors, are there anything related to this task? So look into the job factors, the PRF. So PRF ni ada 3 jenis: job factors, person factors, and organizational factors. It range from divided attention, and then through stress, overload, underload, and even go to peer pressure, organization pressure, work pressure. Okay, so those are actually what we do at safety critical task analysis. Those are the type of question that we ask. And then at the end of the day, we try to put what will be the mitigation measures should look like for this operator, for this specific one line task. So this is only one line. So if you have 100 lines, you have to go through this process 100 times. Okay, all the best to us all. Okay, okay, after safety critical tasks, these are what I call specific HFE analysis, which may or may not concern that type of facilities that you're building. So kalau you're building a non-hazardous, non-toxic place, you may not need so much alarm. You may not need a control room. You may not need living quarters, or you may not need too many human machine interaction. You may have only one. So if you are building a big facility, you may have to consider all of this. So with considerations of oil and gas, big facility, high toxic, and everything nasty about the operations. So these are the 4 main ones that I have extracted. Specific analysis, but not limited to. There may be others that I am not aware of, but these are the common ones that I can share here lah. The first one is control room design and design of the workstation. And the second one is living quarters, particularly for our offshore operations. Alarm design. So alarm design to ensure adequate warning and its ability to recognize during situation based on the alarm criticality. So human-machine interaction is a collection of panels, screen, graphic display, switches, and other technologies used by the operator to monitor and interact with the system. So this will be the part where you turn on, off, you emergency shut down the place where the ESD punya button will be located. Right. And okay, this is the first one, control room analysis and workplace design. So the design shall consider all the critical factors as below. Yang ini, yang ada banyak dalam bulat ni, dalam bubble ni. Space, noise, heat, humidity, ventilation, vibration, lighting, location, layout, ergonomics. So it should be considered where there are introduction of new equipment. If you want to add on new furniture, you have changes in the control room layout, you have changes in location, environment, setting, including lighting and the rest of these factors lah. HFE input may be sought where there is a proposed transfer of operations from control room where there are changes in function, or where the local control room are integrated into larger centralized facilities. Mungkin control room hari tu cuma ada satu panel je, but now the control room dah kena pindah, and then ataupun that control room dah dibesarkan dan bertambah-tambah pula panel dekat sana. So you should not have the same setting. You should not have just one table and one chair and aircon satu saja. You kena expand as as it is lah, you must perform the SCTA tadi, you expect berapa orang dekat kerja dekat sini, then only you can define what will be the layout, what will be the lighting like. Okay, and then these are example of HFE design principle in control room. Okay, it's 10. Control room console with DCS are separated through instrument and communications panel. This is based on ergonomics cockpit design. And console with hardwire display panel hanging above video display unit. So this is the one of the other good design examples lah. And large screen on video walls. Yang ini nampak macam dekat NASA kan, ataupun dekat, I think dalam Malaysia a lot of our big industries and even our military kot, I rasa memang dah ada lah large screen on video walls. So why do we have all this? It's actually to help the operator to work, right? To really prompt them which one is the problematic equipment, which one is having some, which one are working well, and which one is going to give you, sebelum dia jadi situation, catastrophic situation, you can already see what level of operation it is. So sebelum dia penuh ke, and then kalau plan ini ada certain of our design consideration, when we want to design a tank, we have to know what will be the high level and whatnot kan. We put the alarm set at the high level. So as bila dia dah reach that high level, bila dia dah sampai high or whatever that level that decided by the engineers, we still, the alarm will trigger and we still have time to mitigate or to save ourselves lah kalau dah jadi catastrophe. So that is the importance of why we want to have a good control room design as well as the good alarm design. And within the control room design, we have a lot of people working there. So control room and the workplace design lah, what I mean. So impact of vibration need to be addressed as well. So vibration is also a hazard whereby ramai yang terlepas pandang lah. Hence that's why I would like to have it in one slide on its own. So at different vibration frequency, 13 to 20, 6 to 8, there are different target areas of the body that it will impact you. So kalau 13 to 20, kalau you are exposed to it, you will be having a lot of headache lepas tu. And speech disturbance, tiba-tiba stuttering kan, dia tak, susah nak bercakap. Jaw resonance, pharynx disturbance, respiration complaints, chest pain, back pain, abdominal pain, constant urge to urinate, and increase muscle tension. So if generally if you are having vibration at 4 to 9 hertz, you dah ada general discomfort. I believe this one is the one yang kita experience masa kita naik kereta, when we are in a vehicle. And among example of the HFE design challenges, I would like to take this picture is a picture of apa nama dia ni, crane operator. Okay, it is important to understand these guys, what are his challenges, and design his workplace that are human-centric, that he can fit in. So imagine this guy, a crane operator, working high up. Nombor satu, where do you think he go to toilet? Susah kan? So do we design his toilet inside? And then nombor dua, when he is so high up, the heat from the sun really directly impacting him. So did we design in aircon or letak satu kipas kecil bagi dia ala-ala sejuk sikit? Kesian tak dekat dia? And then dia punya kerusi, is it space, the space is too small for him to move and dia tak boleh nak bergerak, dia tak boleh nak berdiri pun. Is it we design cukup-cukup untuk dia berdiri atau kita boleh design untuk dia boleh bergerak, berdiri dan stretch his body? Why not? If we are able to do that, please do so. And the rest of it is about yang tadi tu, safety critical, and then kita ada some human machine interaction, nanti kita tengok. making him sure where he can press the correct button with the intended output. Okay, this is a critical in our operation. A crane operator is a critical critical task lah. So this guy need to be well trained. He needs to be aware of his hazards surrounding him, as well as the hazards that he is posing to the person working with the crane. Okay, working with cranes, sebab crane ni is doing all the heavy lifting jobs, few tons of weight that it can lift from one place to another, which help us. Memang HFE dia memang membantu kita untuk lift a very heavy thing from one place to another. But the hazard that is going to pose to the people is that the crane operation itself. So if the crane experience high wind, the punya load tu akan bergerak kan. So the crane operator needs to know when to stop. Okay, ini terlampau bergerak, I cannot lift now. So he will sign the signal man, cakap saya tak nak buat sekarang because I foresee is very hazardous situation. What if the load snap, jatuh ke bawah and ada orang hit somebody on the ground. So making that decision make an crane operator a very wise person lah. He needs to be somebody very highly trained, sound mental health and alert. Yang tu yang penting. So for a guy like that, we want him to be able to work optimally. We need to provide a very good workstation for him. Okay, he needs to know the correct button, kan macam joystick tu, he needs to move the joystick precisely to what angle, to berapa kepanjangan, berapa meter dia nak gerak, by designing a very safe place for him to work. Okay, so these are the challenges. So biasanya this guy is going to work in harsh weather, strong sunlight, and large proportion of his time is going to be spent in one posture. Sakit pinggang lah, dia tak boleh bergerak macam tu je. So there are studies done for this. And cabin operator, a lot of them retire before the age of 50 due to ill health, macam-macam sakit, particularly musculoskeletal disorders. So crane divers, they are at risk of developing a lot of MSD. Operators are exposed to whole body vibration while in awkward position. Sudahlah dia exposed to whole body vibration. We mentioned just now on vibration. Even slightest vibration that we are in the car pun kita dah rasa tak selesa, apatah lagi he is facing that situation for the whole 8 hours of his working, or if not 12 hours, and in awkward posture. He should not to move too much because he really have to pegang dia punya throttle semua sikit-sikit kan, have to do it very precisely. So his lower back and neck and shoulder are affected the most. So knowing all this, tolonglah kesiankan crane operator. These are one of the example crane operator that I have print out here. Please try to design a workspace that are human centric. Crane operator is just one of them, and crane operators sangat valuable nowadays with all the buildings, ada banyak coming out now. So hopefully they are well protected lah with our HFE design. And here are the anthropometry data and its role. So for you to design that crane operator punya workspace nicely, you need to have the anthropometry data. So if you have learned about anthropometry, it will be much better. So if you have not, so it's actually the study of human body measurements to understand physical variations among human. So dia measure macam ni gambar ni. It measures the length of your hand, your height, and ketinggian kepala and whatnot, and how kalau kita bend berapa ketinggian normal person, average Asian yang the measurement should look like. So why it is important? It is important in design, ergonomics and architecture, where the statistical data about the distribution of body dimension in the population is used to optimize the product tu barang lah ataupun the workplace. So ergonomist banyak there are a lot of professional ergonomists in product design. So for those of you tak nak ada pula mouse ergonomic dekat sini. For those of you who are working at office kan, you selalu guna mouse kan. The normal mouse tu will restrict your blood flow and will increase your risk of carpal tunnel syndrome. So ergonomists knows this and they try to design a mouse where you don't have to stress on your palm. So they design a vertical mouse, they call it. Look out for Shopee, murah je, 50-80 ringgit pun dah boleh dapat. A vertical mouse will free your palm here to be pressed. Okay, so that is an example of an ergonomic design. So takkanlah dekat mouse saja. What about your chair? What about your table? So itu about chair and table, and that is the where most use of this anthropometry data. Okay, sebab anthropometry of average Asian is different from anthropometry of an American or a European, or be it Arabian ataupun dari sebelah mana Japanese. Okay, so our anthropometry data must be established first based on our local current population statistics, right? And how it is being used is in the design of the control room. Macam tadi I mentioned about the design of the ergonomic mouse, design of control room and non-process building. Anthropometry data will be used during HFE design verification via 3D model walkthrough to measure operator maximum and allowable height. So in HFE, in our design processes, so at 3D model, okay, ada tak gambar dia kat sini? Nanti ada sekejap lagi. Through the 3D model, we will put a miniature guide within the software and see whether his hand can reach the valve. His body need to bend when handling, opening and closing the valve. Example macam yang reachability tadi, tiba-tiba ada satu pipe rack dekat depan and then you have to press the button picture tadi kan. So we want to avoid that situation to happen. You have something obstructing you while you are trying to press something behind it. Okay, so anthropometry data is being used there. So these are example. Seated position, kita ada standing position, ada a lot of it lah. These are some example on seated and display surface. So kalau you dah berdiri duduk, you have where does your eyes go? Is it go straight or go up or down? So even with some degree of angle when your eyes go up and down and your neck ni move up and down, is already actually pressing your nerves. So it is important for HFE designers to really take care of how high is high. So if it is too high or if the the DCS diagram is too small, worth for it to use a bigger screen belakang and further away, so that you don't have to do like this or like this. You really only have to look forward straight. So hence that's why dalam tadi gambar the graphic ada a big TV panel. So that is the reason behind it lah. And this one we use the main source of information we get from ASTM, Standard Practice for Human Engineering Design, for this one marine system. Okay, there may be other standards, so you identify it early dekat yang standard definition tadi. So then when you doing the design, you adopt that measurement. Okay, living quarters. So living quarters and process building basically involve architectural design of building. It should reflect the needs of the activities and there are potential to be critical to the health of the personnel or even the process inside that building and also environmental management. With regards to living quarters, sleeping accommodation should be optimized to support recuperative sleep, including it should be located to be free from disturbance from air or structural borne noise or vibration or even other personal punya movement. Okay, thermal environment and ventilation should be controllable and to be suitable for sleeping. This one sebab apa? Sebab shipping design of a living quarters, kalau offshore platform, there are technicians who works at night. So they work from either 6 a.m. to 6 p.m. or 6 p.m. to 6 a.m. So they work at night, and when they work at night, when they finish the shift in the morning sampai his next shift, dia kena tidur lah. He have to have recuperative work during this time in order for him to effectively do his job the next day. So all of these requirement have to be designed in when we do the HFE design lah. Effective means provided to achieve a suitably darkened environment including during daylight hours. So dia tidur masa siang. So siang sepatutnya our body body clock should be up in the morning and sleep at night. But now we are inducing it to be terbalik, to be different. So hence we need to manage and control the environment. We have to mimic our situation where we want to sleep in the morning by darkening the room. So kalau the body detect, oh okay, dah tak ada matahari, is now very gelap, it's night time, it will be much more easier for your body to fall asleep. So that's why we need to consider during the early stage of the design of living quarters lah. And finally, provision of mattress, pillow and bedding that support good quality of sleep. Ini okay lah, kalau you nak beli yang mahal pun ada, ataupun you just nak beli yang biasa pun boleh. Ensuring the layout of functional spaces reflects the need of different groups to be able to interact, communicate and work together. So living quarters not only tempat tidur, it's also tempat untuk recreation, tempat makan, tempat berehat, maybe tempat meeting, tempat beribadah. So those type of considerations need to be put in early stage of the HFE design. So ini adalah example of the standards that we use. Access ways, escape routes, room design, minimum height of the ceiling. So office room ada lain, control room lain, electrical station, basement in offices, basement in substation. Okay, and we also have noise control design limits. Design noise limits, we call it. For indoor location, disturbance of conversation and normal working shall be kept within the acceptable limit. So the noise limit for indoor location indicates as below. So untuk areas in workshop, where communication is required and workshop for light maintenance is 70 dBA. Workshop offices, control room, computer room is 60 dBA. Control room not continuously manned, open plan, social room 50 dBA. And last kali is offices and conference room. Ini 45 dBA. So 70, 60, 50, 45 ni should be taken into consideration within the earliest HFE design. Okay. So in Malaysia, all buildings layout and detail shall be submitted to local council for application of certificate of fitness and in compliance with the Unified Building Bylaw requirement, UBBL. Ni adalah example gambar a typical offshore galley, a typical offshore living cabin, although those places that I have been is not as cantik as this one lah. This one macam hotel lah nampak. A typical offshore recreation area. So when you design living quarters, these three aspect memang akan kena design in. There are situations where I experience they design bilik tidur living cabin ni, sebelah tu ada very noisy equipment dengan vibrationnya, dengan noise level yang tinggi. So itulah masa tu, that was among the experience lah. So that happened and we were thinking, why was it not captured in one of the HFE stages. So hence the importance of HFE specialist experience to know what to look for when you design a living cabin. Do not design a very noisy or vibrating equipment next to it. Okay, sometimes offshore facilities ni memang, bukan sometimes, all the times they are very limited spaces. So dekat situ jugalah nak letak, dekat sini jugalah nak kena kena adjust letak pump dekat sebelah dekat living cabin. So boleh tak kita adjust, itulah macam you adjust your furniture dekat rumah kan. So during the design phase, it will be very fun to do. Try to adjust sini boleh, macam tu. Okay, and on the noise design requirement, so we require the designer to conduct a predictive noise control study, whereby you try to mimic or model the actual noise based on the equipment that is being emitting that area. So yang noise limit tadi is only for indoor, but the noise limit outside the process area is actually 85 dBA lah. We just follow DOSH PEL for noise. The new PL is 85 dBA. Okay, so from there actually we can utilize the same prediction of the equipment to proceed with the noise measurement and subsequently the noise risk assessment when handed over to operation stage later. Okay, this is a snapshot or example of how a 3D model review look like. So you can actually just use any 3D modeling software that are available out there. But the actual measurements need to be in. So this one is actually we've already simulate a working person working there, sleeping there, sitting, twisting the door, angkat item from cabinet dekat atas. So we need to know whether the hand sampai ke tidak. Is it we are designing too high or too low? Alright, so this is an example of what a 3D model review look like. Okay, so that is on living quarters. This is, I think, the second last one on alarm design. So I think alarm design is quite a dry topic and a whole set of processes that is involved lah. But suffice to know for us today that alarm is an audible or visible means of indication to operator on equipment malfunction, process deviation or abnormal condition which requires them to respond to it. Alright, so if the process, the intended process is working nicely, so A to B to C to D dapat satu produk, A to B to C dapat satu produk. Okay, kalau dia working nicely, not a problem. From A to B, go to C, something happen here because ada certain piping tersumbat ke apa, then this is where the alarm is needed. So if you don't have an alarm, A to B to C sangkut, A to B to C sangkut, A to B to C sangkut, and then lama-lama pressure build up dekat C, it did not go to D, hence no product is being produced. So lama-lama sangkut dekat that equipment C. It can be very catastrophic where if kalau kita ada high pressurized vessel and lama-lama pop dia meletup without us knowing it if we don't put an alarm to it. So an alarm is dia punya function or dia punya role, why we put alarm there is to give us early indication or before catastrophic things happen. So what is alarm management? Alarm management is managing the life cycle activities to optimize the risk and the performance of the alarm. So alarm management pula, when we have too many alarm that the operator need to address, dia nak kena go check alarm yang ini bunyi, pergi check alarm yang ini. So when there are too many alarms, so we need to prioritize which alarm that we should attend first. So hence the importance of alarm management, right? And all of this will not work without an alarm philosophy. So the objective of an alarm philosophy is categorizing and prioritizing alarm, determining acceptable alarm frequencies and alarm set points. Functionality, it is a functionality required for alarm handling, annunciation, acknowledgement, and reset, alarm shelving, and alarm logging. Okay, the next step in the alarm design process is to identify the alarm that are required to be included in the alarm system, including any existing alarm that may require modification. Alarm rationalization process should then be carried out in order to categorize alarms by priority based on the rules established in the alarm philosophy. So untuk alarm ni, it has already a whole set of process flow lah, from philosophy, identify, rationalization, design, implementation, training, operation. So some up to training, operation and maintenance lah. Okay, and our role as HFE designers is at the design stage here. Okay, identify, rationalize and design. So we want to design that it should not be too much sampai kita overrule ataupun reset saja balik, padahal is actually a real catastrophic alarm that we are resetting. So kita tak nak perkara tu berlaku lah. Hence the importance of understanding what the alarm intention and rationalization looks like. I think this is the last fundamentals of the elements within the HFE design processes, the human machine interaction or HMI. So it is a collection of panels, screens, graphic displays, keyboards, switches and other technologies used by the operator to monitor and interact with the system. So the design of the HMI plays a critical role in determining the operator's ability to effectively manage the operation, especially for responding during abnormal situation. The layout and visualization of the DCS or the distributed control panel shall be designed to support operators to execute safe and efficient plant operation. So we want to eliminate poor HMI design lah. Poor HMI design will cause confusion, operator fatigue and low situational awareness. Hence, dia akan menyebabkan catastrophic incident berlaku. So biasanya ada ke slide lepas ni? Oh tak ada. So biasanya about the human machine interaction, kalau the simplest way that I can share is about you and your handphone kan. Dulu handphone button besar, button kecil kan. Sekarang ni is all the on your tips, right? And even with the latest trends of the smartphones, which are competing with each other, they are offering better and better quality ke? Quality of what? So that's my question. Quality of what? Kenapa you prefer a certain brand on top of another brand? It's because of how it interacts to your eyes, isn't it? How better colour yang ni, screen bagus ringan, satu yang ni berat, ini ringan. Oh senang I nak tekan. So those elements are the one you decide to buy brand A punya phone dengan brand B punya phone. Similar to this human machine interaction punya human factor considerations. So if we give the operator a design a monitor yang ada black and dark blue, the operator will not be able to distinguish what will be the outcome atau what he's supposed to do just because of the color contrast. And bila dia dah tak nampak color contrast, he have to strain his eyes and his brain more for him to understand what is the current situation now. I cannot see, it's too small, the font is too small. Oh, kalau kita beli a good HMI, a good visual display unit, macam in the middle and the right hand side ni kan, black against stark green or black against yellow macam tu. So an operator will be able to see it from even daripada jauh lagi, and his situational awareness comes better. Bila ada alarm, dia terus blinking color red, and if it is working perfectly, it change back color to green, example macam tu. So these are the consideration for human machine interaction that we as a HFE during the HFE design should consider lah. The simplest analogy is your phone just now. So kalau you suka phone yang macam ni sebab dia nampak lagi clear lah, mata I dah start rabun, I prefer to buy this phone lah, I tak nak buy this phone lagi. So that is actually HFE. Hence these are examples of this guy have to monitor and address each of the alarm by himself by looking at all these panel. Rasa-rasa dia feasible, boleh buat ke tak? Too many alarm, too many panels for him to see, and if all goes alarm serentak, and how would you think he react? Okay, and okay, that will be, this is my last slide on the conclusion. HFE focuses on the application of human factor knowledge to the design and construction of a socio-technical system. It is important for us to acknowledge the main objective of HFE is to ensure system are designed in a way that optimize the human contribution to production and minimize potential for risk to HSE. So in summary, the fundamentals of HFE in design process comprise of HFE screening, valve critical analysis, safety critical task analysis, and those several specific design analyses, alarm, human machine, design of work location, etc. Okay, I think I have reached the final slide. So far, thank you very much to the organizer. So far, any question?
Thank you, Puan Mas Farita. Any question from the audience? You can unmute the mic or paste in the chat box. If no question, can everyone open the camera? We want to take a photo with Puan Mas Farita. Okay. Anyone to open the camera? Okay, ready? 1, 2, 3. Okay, one more. 1, 2, 3. Okay, thank you, Puan Mas Farita.
Thank you very much, everyone.
Okay, we will having a short break. We come back at 11 a.m. with our next presenter, Mr. Solihin from Uni KL.